Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the top 25 TSQL in Microsoft Fabric interview questions for 2025. Perfect for data engineers, analysts, and anyone preparing for Fabric Warehouse, Lakehouse SQL endpoints, or SQL analytics roles. We cover usage in Fabric, differences from traditional SQL Server, interaction with Delta Lake data, analytical features, performance, security, integration with Power BI and pipelines, error handling, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. How is TSQL used in Microsoft Fabric? TSQL is primarily used in Fabric Data Warehouse for full DDL, DML operations, including table creation, data ingestion via CTAS, copy into, and complex analytical queries. In Lakehouse SQL Analytics endpoints, TSQL provides read-only querying of Delta tables, supporting select statements, views, functions, and object-level security. TSQL enables cross-database, workload queries joining warehouse, lakehouse, and mirrored databases within the same workspace. Integration with notebooks via %TSQL magic commands allows execution of TSQL alongside Spark code for hybrid workflows. 2. What differences exist between Fabric TSQL and SQL Server TSQL? Fabric Warehouse supports a broad TSQL surface but lacks some on-premises features like full replication, certain agents, and legacy options, focuses on serverless analytics. Lakehouse SQL endpoints are strictly read-only, prohibiting DML, DDL that modifies data, unlike full transactional support in SQL Server. Fabric emphasizes analytical extensions, e.g., OpenROWSET for files, enhanced CTEs, with automatic optimizations, differing from SQL Server's manual tuning requirements. Authentication relies solely on Microsoft Entra ID, without SQL logins, and integrates natively with OneLake, Delta Lake formats. 3. How does TSQL interact with Lakehouse data? TSQL queries Delta tables in the Lakehouse via the auto-provisioned SQL Analytics endpoint, treating them as relational tables. Metadata synchronization automatically reflects Spark-created, changed tables, with manual refresh options for immediate updates. Supports read-only operations including joins across Lakehouse tables and shortcuts to external data sources. Enables creation of views and functions on Lakehouse data for abstracted, governed consumption. 4. How does TSQL support analytical workloads? Advanced analytical functions like windowing, overclaws, CTEs, including nested and pivoting, handle complex aggregations and rankings. Integration with Warehouse Engine provides cost-based optimization, statistics, and adaptive execution for large-scale analytics. Cross-database queries unify data from multiple Fabric items for comprehensive reporting. Supports materialized views and procedures for reusable analytical logic. 5. How does TSQL handle large datasets? Distributed processing across Fabric capacity scales queries on petabyte-scale Delta tables with automatic partitioning. Predicate pushdown, column pruning, and data skipping minimize scanned data volumes. CTAS and select in to enable efficient materialization of subsets or aggregates from massive sources. Autoscaling bursts resources dynamically for high-volume analytical queries. 6. How does TSQL optimize query performance? Automatic Statistics Collection and Maintenance Guide, the cost-based optimizer for efficient plans. Delta Lake features like optimize, Z-order, and clustering, invoked indirectly, enhance file pruning and scans. Query hints and adaptive execution dynamically adjust for skew and runtime conditions. Result caching and in-session temp tables accelerate iterative analysis. 7. How does TSQL manage indexing and partitioning? No manual indexes. Relies on automatic clustering, Z-ordering, and partitioning for data skipping and optimization. Partition tables support elimination based on query filters for faster access. V-order write optimization improves compression and sequential scans. Statistics replace traditional indexes for optimizer guidance. 8. How does TSQL handle transactions? Warehouse supports ACID transactions for DML operations with snapshot isolation. Lakehouse endpoints provide read-consistent snapshots without modification capabilities. Limited multi-statement transactions in endpoints focus on analytical consistency. Integration with Delta Lake ensures atomicity in underlying writes. 9. How does TSQL support stored procedures? Warehouse allows creation and execution of stored procedures for encapsulated, reusable logic. Procedures support parameters, error handling with try, catch, and modular analytics. Callable from pipelines are external tools for orchestrated executions. Lakehouse endpoints support read-only procedures for query abstraction. 10. How does TSQL manage concurrency? Serverless autoscaling handles high concurrent queries with workload smoothing. Snapshot isolation prevents blocking between readers and writers. Throttling and priority management balance resource contention. Monitoring tracks sessions and prevents overload. 11. How does TSQL support views and functions? Standard and, where supported, materialized views abstract complex joins for simplified consumption. Scalar and table-valued functions enable reusable calculations and logic. Views inherit security for governed access control. Supports schema binding for performance in analytical scenarios. 12. How does TSQL integrate with Power BI? Direct connection via SQL endpoint enables live querying for semantic models. Direct Lake mode leverages endpoint for metadata and fallback execution. Views and procedures serve as optimized sources for reports and dashboards. Cross-workspace joins unify fabric data in Power BI. 13. How does TSQL handle data security? Microsoft Entra ID authentication with RBAC at workspace and object levels. Grant, revoke for granular permissions on tables, views, and schemas. Row-level and column-level security enforce dynamic filtering. Sensitivity labels propagate compliance policies. 14. How does TSQL manage query plans? SHOWPLAN_XML exposes detailed logical and physical plans for analysis. Cost-based optimizer uses statistics for efficient execution strategies. Adaptive query execution refines plans at runtime. Monitoring hub visualizes historical plans and performance. 15. How does TSQL support window functions? Comprehensive overclaws with partitioning, ordering, and frames for rankings and aggregates. Supports rows, range specifications for precise analytical calculations. Enables running totals, moving averages, and lag operations. Optimized execution in distributed warehouse engine. 16. How does TSQL handle data type conversions? Implicit conversions occur automatically based on data type precedence rules, while explicit cast and convert functions provide precise control over type changes and formatting. Try_cast, try_convert, and try_pass return null on failure, enabling safe conversions without raising errors in analytical queries. Integration with Delta Lake schema evolution supports compatible type adjustments during metadata sync and query execution. Format function handles culture-specific and custom string conversions, useful for reporting and localization scenarios. 17. How does TSQL support error handling? Try/catch blocks capture exceptions, allowing graceful recovery, logging, or custom error propagation within scripts and procedures. Functions like error_number, error_message, and error_line provide detailed diagnostic information for troubleshooting. RAISERROR and throw statements enable custom errors with severity levels and state codes for controlled flow. XACT_state and transaction control ensure proper rollback or commit behavior in warehouse transactional contexts. 18. How does TSQL integrate with pipelines? Script activity in data pipelines executes inline TSQL statements for data loading, cleansing, or post-processing tasks. Stored procedure activity invokes parameterized procedures directly within orchestrated workflows. Dynamic content expressions pass runtime values to TSQL queries for flexible, reusable logic. Unified Monitoring Hub aggregates execution metrics, logs, and dependencies across pipeline-integrated TSQL activities. 19. How does TSQL support incremental processing? Filtering predicates on partitioned or timestamp columns enable efficient incremental scans of only new or changed data. CTAS with where clauses materializes incremental results into new tables while preserving historical partitions. Integration with change data feed allows querying row-level deltas for precise incremental logic. Merge statements, in warehouse, support upsert patterns for maintaining incrementally updated targets. 20. How does TSQL manage schema changes? Warehouse supports alter table add, drop, alter column for direct schema modifications with immediate effect. Lakehouse endpoints reflect schema evolution via automatic or manual metadata refresh after Spark operations. Views and synonyms abstract underlying changes, maintaining stable interfaces for consumers. Delta Lake column mapping and schema enforcement prevent incompatible alterations during sync. 21. How does TSQL support automation? Scheduled pipelines trigger recurring TSQL script or procedure executions for automated refreshes. REST APIs and Fabric SDK enable programmatic submission and monitoring of TSQL queries. Stored procedures encapsulate complex logic for repeatable, parameter-driven automation. Integration with monitoring and alerts supports event-driven or conditional executions. 22. How does TSQL ensure data consistency? Snapshot isolation level provides consistent, Non-blocking reads even during concurrent writes in warehouse. ACID compliance guarantees atomic commits and rollbacks for transactional operations. Delta Lake underlying format ensures versioned, immutable writes with time travel capabilities. Metadata synchronization maintains alignment between physical storage and queryable schema. 23. How does TSQL optimize resource usage? Efficient query patterns with selective columns and strong predicates minimize data scanning and compute allocation. Serverless autoscaling provisions resources only during active query execution, eliminating idle costs. Automatic statistics and adaptive execution prevent wasteful full scans or suboptimal plans. Capacity throttling and workload management ensure balanced utilization across concurrent sessions. 24. How does TSQL support enterprise reporting? Pre-aggregated views and materialized tables provide optimized sources for high-performance Power BI reports. Cross-database queries consolidate disparate Fabric datasets into unified enterprise views. Direct Lake integration delivers sub-second response times on large analytical tables. Governance features like endorsements, sensitivity labels, and object permissions ensure trusted reporting. 25. What are best practices for using TSQL in Fabric? Use Fabric Warehouse for modifiable, transactional workloads and Lakehouse SQL endpoints for read-heavy analytical queries with regular metadata sync. Implement partitioning, clustering, and periodic optimize, vacuum on underlying Delta tables to maintain performance. Always use views for abstraction. Apply granular security through object-level permissions, RLS, and column masking. Monitor query performance via hub and tune with statistics. Favor incremental patterns with CTAS, merge. Integrate with pipelines for orchestration, and document procedures, views for maintainability. Thank you for watching. If this video helped you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.